Recording.
Oh no, the video clips.
All right, so today we got 7.2. Areas in the plane. So area between two curves is what we're looking at. And they have this drawn, rather nicely, but let's go a little more basic than that. If we have this one curve here and another curve like this, to find the area between the two curves, we're going to take the area of the top curve, right there, and we're going to minus out the area of the bottom curve. So we're going to go top minus bottom. So if we subtract out the area under the bottom curve, what we have left is the area between the two curves, like that. So it's top minus bottom, and that's essentially what this box is telling us. Find the integral of the top curve minus the bottom curve. And you'll have the area, what's left is between the two curves. Any questions on that? Applying the definition. Find the area of the region between y equals secant squared and y equals sine x from 0 to pi over 4. So here's the curves. They've given you the curves. We see the area. So we're going to take the integral from 0 to pi over 4. And the top curve is secant squared. Whoops, I don't need dx yet. Top minus the bottom. Sine of x dx. So top minus bottom. We have tangent of x plus cosine of x from 0 to pi over 4. So tangent of pi over 4 plus cosine of pi over 4 minus tangent of 0 is 0, cosine of 0 is 1. So 1 plus square root of 2 over 2 minus 1. So it ends up being square root of 2 over 2 is the area. Units squared, feet squared, miles squared, whatever it is. If they don't give you units, don't worry about it. We're good there. Square root of 2 over 2. Top minus bottom. It gets more complicated than that, though. Find the area of the region enclosed by the parabola 2 minus x squared and the line y equals negative x. So one way it could get a little more complicated is we need to know these two intersection points. Now from the graph you can tell, I think you can tell it's from -1 to 2, but what if I didn't give you the graph? I would definitely put this on the non-calculator part of the test. You wouldn't need a calculator at all here. We set them equal to each other. Hopefully that's fairly obvious. And we solve. So 0 is equal to x squared minus x minus 2. So x minus 2, x plus 1. So there's the 2. There's the -1. So they're intersecting at -1 and 2. That defines the enclosed area. And we're going to integrate from -1 to 2. But you'd have to be able to look at this and get a kind of a sketch of this, or at least know which one is the top equation and which one's the bottom equation. So the top is the parabola. 2 minus x squared minus I'll put minus a negative x, which is a plus x in the end. So 2x minus 1/3 x to the third. That's going to be plus x. So how about plus 1/2 x squared? Yeah, that looks good. And from -1 to 2. So 4 minus 8/3 plus 4 over 2 is 2. Minus, that's going to be -2, right? Yeah, minus -2. Minus 1/3, no, plus 1/3. And then plus 1/2, I think. I hope. 4 plus 2 is 6. 6 plus 2 is 8. So 8 minus 8/3 minus 1/3 minus 1/2. If you run the negative through. Oh boy, 6. 48 minus 16 minus 2 minus 3. 32 minus 2 is 30. I'm getting 27/6. 27/6 are 9 halves, right? Divide by 3. I got 9 halves. I expect to be able to do that, the integral part. So if I do some calculation errors, forgive me, but that's what I've been getting all day. So I'm pretty sure that's right. We all good here? Yeah, all right. Find the area of the region enclosed by the graphs of 2 cosine and x squared minus 1. Well, what I notice about this graph is it is symmetric over the y-axis. In other words, both of these are even functions. Now we're asked to use a calculator, so this wouldn't matter as much using a calculator, but if I were to do this by hand, I would do this. I would double, and I would go from 0 to the intersection point. Top minus bottom. Cosine is the top. And the upside down, no, excuse me. Oh, no, yeah, and the parabola is the bottom. So minus x squared minus 1 dx. Now, we're going to need a calculator for this because the intersection point's a decimal. So let's grab calculators. I'm going to do some parametric stuff, so you definitely want to play along today. You need to practice this. I'm not going to do parametric for this one, though. It's not necessary. All right, well, y equals 2 cosine and x squared minus 1. And if we go zoom 6, that seems to be big enough to see. We could zoom in a little bit, and that's what they've done in the graph over to the left there. But we need the intersection point, and I don't need the negative one because it'll be the same, except negative. So let's go intersection, enter. 1.265. 1.265, 4237. So there I've written out. Now AP does not like what they call bald answers. You still need to write down what you're entering into the calculator to get the answer. So we've done that. Now we can do calculator stuff. But notice that it says x equals this number. So as long as you've calculated something and x holds a value, it'll still hold that value, and I can use x. So we're going to go to math number 9. I split it over and doubled, so I can go from 0 to x. Now, because I'm using a calculator, this wouldn't matter. But like I said, if you're doing this by hand, I like plugging in 0. I love plugging in 0. So whenever I can, I'm going to plug in 0. All right. Oh, but didn't I put them? I graphed these. So variables y1, that's the cosine, minus variables y variables y2, x. Oh, and I do want to double it. So 4.994, what I do want to show you is if we go up here and grab this, and let's say I don't want to double it. I don't want to split it over the y-axis. We can delete. I can go negative x to x, and we should get the exact same answer because there's symmetry, because they're even functions. So we'll get the same thing. If they're not even, you can't do that. You can't split it. 4.994 or 4.995. Integrating with respect to y. Find the area of the region, example 4, by integrating with respect to y instead of x. So if we were to integrate with respect to x and go from 0 to 4, I'd have to split this at 2 because we have this area under the curve from 0 to 2. Then we have the area between two curves from 2 to 4. So I'd have to split this with 2 integrals, which is not a huge deal. It would be a little bit more work to do it this way. Our option is, instead of integrating with respect to x, we can integrate with respect to y. So we can integrate from 0 to 2. 0 to 2, we're going to go along the y-axis. And instead of a top minus bottom, we have a right minus left. So we'll do all of this area minus this area. That gets the area in between. As a matter of fact, both of these say x equals instead of y equals. But now we're going to go right minus left instead of top minus bottom. So y plus 2 minus y squared dy. 1/2 y squared plus 2y minus 1/3 y to the third. Love plugging in 0, by the way. I like that. So from 0 to 2. 4, 2 plus 4 minus 8 thirds, 6 minus 8 thirds, 18 thirds minus 8 thirds. I'm getting 10 thirds. Because when we plug in 0, all of those go to 0. Now be careful with plugging in 0 because the cosine of 0 is not 0, it's 1. So be careful with that. E to the 0 is not 0 either, it's 1. So be careful when plugging in 0. It's not always 0. Any question on this concept? Right minus left instead of top minus bottom. Sometimes it's better. Sometimes it's more efficient. Just goes quicker. If we split this into 2 integrals, it would just take, you still get the same answer, just a little more work. Find the area of the region enclosed by y equals, it says, example 6 says making the choice. So this one says y equals, now we get to choose, well that says x equals. But we can't do both, we got to pick one. They provide the graph over there, but what if we didn't have that? Oh, I can't, I was going to delete the graph, I can't delete part of it. Anyway, what if you didn't have that? The problem would be, well, the problem is anyway, we need the intersection points. And to do that, we don't have to graph this. I'll tell you what, let's get the intersection points, and then I'll show you how to graph that on your calculator. I still have to pick. And I want to do this right minus left. The reason we can't do top minus bottom is how are you going to do top minus bottom with its own equation? It'll be 0. That area will say 0 because the top is x to the third, or excuse me, y squared minus 2, and the bottom is y squared minus 2. That'll be 0. Can't do that. So we have to go right minus left. We don't have much of a choice here. Maybe we could get it to work, but we'd have to really think about it. If I go x equals the third root of y, then both of them say x equals, and it makes life a little easier. Let's do the intersection points. We have y equals. This is where you might want to play along a little bit, especially the next thing we do. Number 4 is third root, kind of built in. Oh, let's clear that. Math, number 4, third root of x. The variable doesn't matter here if we're just finding intersection points. This is y squared or x squared minus 2. Let's get all the other stuff out of there. Oh, let's just clear it. Clear it. X squared minus 2. And we're going to graph this. But it's not going to look the same because it's kind of, we used x's instead of y's. That's why it doesn't look the same. So we're going to have to figure out where we're at. Now we're doing right minus left. So I really want this intersection point here and this intersection point here. So I want A, and I want B. A is around -1, which is actually over here. It's off to the left. So the bottom one on our graph is off to the left. So second, calculate intersection. I want this one over here. Enter, enter, enter. -1. So it is -1. So we're going to integrate from -1, and now this one is up here, which is actually over to the right. Because remember, we're using x's instead of y's. So it kind of turns things around a little bit. Intersect, we'll move over here. I think it's like 1.7-ish, if I remember right. 1.793. 1.7930037. That should be plenty accurate. But let's say you didn't have this equation, that you didn't have this graph, and you're not sure which one's the right one, which one is the left one. We're going to do this. Everybody ready? This is what you need to practice a little bit. We're going to go to mode. Go to mode. And in order to graph with respect to like x equals, we're going to have to go to parametric. Because the normal function mode has to be y equals. So we're going to go to parametric. If you go to y equals, now it has an x and a y. And these say x equals and x equals. So let's go x equals the third root, math number 4. Third root of, they're parametric, so the parameter is t. Now, the y, we're just going to make t. So that'll get us the first equation, the x equals third root of y. Now, the other one is y squared minus 2. So we'll go t squared minus 2. And the y will be t. When we graph it, yours probably won't show that. Yours probably has this little, like, just piece of it, right? And if you go to your window, this says 0 to 6.28. You guys see that in your window? So it's built for trig. It's not built for polynomials or anything other than trig. So to see the whole graph, we're going to go negative 10 to 10. And now yours should fill the screen just like mine did. So if negative 10 doesn't fill the screen, go from negative 20 to 20. All right, well now you would be able to see, the x to the third is the right equation, the parabola is the left equation. So now we can finish it up. So we have third root of y minus y squared, minus 2. We need those parentheses, dy. We can skip then you plug it into your calculator and find the answer. Because we're using calculators anyway on this one. Any questions on setting up this one? Then we plug it in and get an answer. Because that nasty decimal, we're not going to do this one by hand. Everybody okay moving on? All right. So that's parametric. That's how you can graph these when it says x equals. You kind of got to know that right there, how to do that. And the way I think of it is they say x equals. They say x equals, so I put the equation in the x equals. The other one just gets the t. All right, let's see what else we have. Oh, that's pretty much it. Let's kind of practice it a little bit. Let's do the first one by hand. Yeah, we can do this. Oh, yeah, we definitely need to do this by hand. This one's a long one. Here we go. First of all, what I notice is symmetric over the y-axis. And if I'm going to do it by hand, I really want to plug in 0. I'd rather plug in 0 than negative pi over 3. So we're going to double the area, but we're only going to calculate half of the area. 0 to pi over 3. So they give us the intervals. We don't have to calculate any intersection points. Top minus bottom. 1/2 secant squared t minus the bottom function is negative 4. So let's go plus 4 sine squared t dt. Now I want you to write down everything I wrote down, everything on this one, because you need to know this stuff, especially when we do polar in second semester. We don't know how to integrate sine squared directly. We have to make a substitution. So here's what you need to know. What we have to use is the double angle formula for cosine. So cosine of 2t is cosine squared minus sine squared. That's right from pre-calculus. You're also told in pre-calculus there are 3 choices. There's the first one. If you make cosine squared 1 minus sine squared, that's 1 minus 2 sine squared. Because you get 1 minus sine squared gives you 2 of them. If you make sine squared 1 minus cosine squared, you get 2 cosine squared minus 1. So there's 3 choices. The one that we want is the middle one, because we're trying to replace sine squared. So we're going to minus 1 over. And divide by negative 2. So the replacement we can make for sine squared is, let's see, we have 1/2 when we divide by negative 2, and minus 1/2 cosine of 2t. That's the replacement that we can make, because now we can actually take the integral of that, not sine squared. So we have a new one. We have 2 integral 0 to pi over 3 of 1/2 secant squared. That's going to be tangent. We know that one. But I'm going to replace sine squared with this. Now, if I run the 4 through, those are going to be 2's. So plus 2 minus 2 cosine of 2t. You guys all right with me skipping that step? Everybody good? Run the 4 through? Very good. All right, let's finish it out. This is 1/2 tangent of t plus 2t. And then now this is going to be, let me think, minus sine of 2t from 0 to pi over 3. Because the derivative of sine of 2t will be cosine of 2t, but then times 2, times the derivative of the inside. When I plug 0 in, all of these are 0. Tangent of 0, 2 times 0, sine of 0. So that's good. So all I have to worry about is the pi over 3 now. 2 times 1/2. Pi over 3 is 1/2 square root of 3 over 2. So the tangent of this is sine over cosine, which is square root of 3. Got to remember your trig a little bit too. Plus 2 pi over 3 minus sine of 2 pi over 3. 2 pi over 3 square root of 3 over 2. Well, this is square root of 3 over 2. This is square root of 3 over 2. So I get 4 pi over 3. That's a doozy. That's a doozy because of that stinking sine squared in there. That's what makes it a little longer. That one's a little rough. But don't worry, you're going to be an expert at it after we do polar, which is kind of a cool little chapter. And it doesn't take very long either. There's not much to it. All right, let's keep rolling, everybody. I picked this one because of the sine squared and because of the symmetry. So a couple reasons to pick this one. Pick this one because this one's just a right minus left. We're going to do integral from, this is, it's 0 to 1, but it's this 0 to 1. It's 0 to 1 along the y, because in the end we're going to put dy. So you got to go along the y-axis. And it's pretty, I think they made it pretty clear what's the right and what's the left. Right minus 2y squared minus 2y dy. I hope it's clear to you that if this was on a test, you would finish it out, you would do the integration, you would give me an answer. Is everybody okay with me skipping that on this? Because it's just polynomials. I assume you know how to integrate a polynomial. Everybody good? Got it written down? We got it set up. Now the integration would be next. All right, so there's right minus left. This one's a little different in that, well, there's two options. We could split this up here and go integral from 0 to 1 of x squared dx plus integral from 1 to 2 of 2 minus x. Or, let's see, what would we need to do? We'd have to go from, oh no, not 0 to 1. Oh yeah, 0 to 1, 1 to 2. This would be 0 to this one of right minus left. But now if I'm going to go right minus left, I need x equals 2 minus y, and x equals square root of y. Now I know that you're thinking, well, don't you need plus or minus? But it would only be the positive side. It's only the positive branch of that parabola. So I wouldn't need the minus. We could do 2 minus y minus the square root of y. Right minus left dy. Those two should give us the exact same answer. So you'd have to either split it up or go right minus left, one or the other. So I picked 10 because of, just you can split it. You got choices. 14, I picked this one because they keep switching positions, the top and the bottom. Now they're both y equals, but it's line over parabola. So we go -2 to -1 of negative x plus 2 minus 4 minus x squared, top minus bottom. But now from -1 to 2, they trade positions. So plus -1 to 2 of 4 minus x squared minus negative x plus 2. And then 2 to 3, they switch positions again. So plus 2 to 3 of line minus parabola. So negative x plus 2 minus 4 minus x squared. And I'll spare you the torture of finishing that. That'd take a while and serve not much purpose. Unless you really don't know how to integrate polynomials, then it would serve an awesome purpose. But I think we're pretty good at that by now. So I picked that because they trade positions twice. They trade positions. Do I have anything else? All right. No calculator. What if I put this on a quiz right now and handed it to you? Could you do it? Go. No calculator. Oh, they're x equals. So that means we probably should just do right minus left. But the problem is twofold. First of all, we need intersection points, which is pretty straightforward. Minus y minus 2 is 0. So y minus 2, y plus 1. So y equals 2, y equals negative 1. I should have you go guess speak in Algebra 1 and say we still factor. That is pretty important to know how to factor. Anyway, so now we know we're integrating from negative 1 to 2. And then the other thing, and then you have it pretty much whooped, is what's the right and what's the left? Well, y squared is going to look like this. And then we have this line. I would graph the line like normal, minus the 2 over x minus 2. So now we have a y-intercept of 2 with a slope of 1. So there's your negative 1, and this must be up here at the negative 2. There's your bounded area right there. So it looks like the line is on the right side, and the parabola is on the left side. And we're integrating with respect to y. How'd we do? Were you able to get that far, maybe? If you could, that's great. If you can't, well, we got to practice it a little bit. Let's finish this one out. Four over 2 is 2 plus 4 minus 8/3. There's the 2. Minus, that'll still be, let's see, that'll be a half. That's minus 2. And that'll be plus 1/3. All right, so 2 plus 4 is 6. How about we go 2 plus 4 is 6, plus 2 is 8, minus 8/3, minus 1/2, minus 1/3. 6 again. So 48, 16, 3, 2. What is that going to be? 32 minus 3, 29, 27, 6. So 9. Did we get that? I think we got that answer before. Yeah, it's real similar. The same answer. Slightly different. Probably the same, similar equations too, I'd imagine. Anyway, questions on this? So you got to kind of decide what's better, top minus bottom or right minus left. All right. Let me shut this down.